So these are those notes. Let me get to the next thing here. All right, so what we're doing Extrema first. Extrema. How's it looking? Is it okay?
It's a little bit.
Yeah, I know, it's kind of slides. This is a lot more difficult than it looks like. All right, so here's what we got. If I gave you, let's just look at this first. If I gave you this, would you say that there is a maximum and or a minimum involved here? A maximum and or a minimum? Definitely a minimum. Is that okay? Like, right, so we're down here, right? This is the minimum down here. Where's it at? Right here. This is the minimum?
Yeah.
Why is there no maximum?
Because it
Because it goes up and up forever and ever. Is that okay?
Yep.
All right. So here's something that I would add to those notes. Let's do it over here. So here's what you want to think of an extrema. Extrema is any hill or valley. And so like, I'll put those in parentheses, right? Hill or valley. And so then I'm calling this thing, right, this parabola, I'm calling that a valley. Is that okay? Okay? So anytime there is a hill or a valley, that's an extra extrema. Fair enough? So this is actually, not only is this a minimum, but you could also call this an extrema. Okay? And then you guys had a relative maximum, or did they call them relative maximums? They just said relative extrema, right?
No, it's relative maximum.
It was maximum. Okay, so then this is also a relative minimum. All right, now on the computer, sometimes they only say, oh, that's just a minimum and not a relative one. If I say local on accident, that's because relative and local are the same thing. Is that okay? All right, so then, oops. All right, so then let's look at this. All right, so first question, how many extrema are there? Two, is that okay? Is there a minimum?
No.
No. Is there a maximum?
No.
No, there is no maximum, right? These are going on forever, right? So no minimum, no maximum. Is there a local minimum?
Yeah.
Right here. I'm sorry, relative minimum, right? There is a relative minimum here. And then a relative maximum here. Is that okay?
Where's the relative minimum?
Relative minimum,
Oh.
okay, relative maximum. Is that good?
Yeah.
All right. Undue point. I mean undue point. What? Yeah. All right. I guess I'll go to the next one. Thing there. All right. How about is there? Well, firstly, how many relative extrema are there?
Five.
Five. Is that okay? Right? 1, 2, 3, 4, 5. Is there a minimum?
Yes.
There is a minimum, right? It's not ever going to go below this. Okay, so again, it's like, it's never coming back, okay? So minimum. What about a maximum? Is there a maximum?
No.
No, there's no maximum. What is this one? This one's called a minimum. You could call it a relative minimum. What about this one?
Relative maximum.
Relative maximum.
Relative minimum.
Relative minimum.
All right, is that all right? All right, so then here's the next one. End behavior also. And so what I would have in your notes is just give yourself a blank coordinate plane and then label this top one positive infinity, the right one positive infinity, and then negative infinity, and negative infinity. Because that's most of what we're talking about. And then all of these sketches I would just add alongside there. And there's some notation that you're going to have to get used to, but it's not the worst thing once you get a look at it. And this is the notation. These arrows actually mean something, okay? This is kind of like the introduction to limits for anyone that's going that far. And so here's the sketch. This is the first one we're going to look at. And so I'm going to put infinity here. Now this is red as x approaches infinity, right? The arrow means approaches. Or you could also say as x goes to infinity. So in this direction, this is where x is going to infinity. Is that okay? Out to this way? And so then your question is, as x goes to infinity, all the way out, what is your y value doing?
Staying the same.
Is it staying the same?
It's
Rising.
It's rising, right? So it's increasing, and this means it's never coming back. All right, so then as x goes to infinity, then we're going to say y is going to infinity. Is that okay? As x, oops. Right, as x goes to infinity, y is going up and up and up and up to infinity. All right. What about as x approaches negative infinity?
Then y goes.
Y is decreasing, so then you're going to say to negative infinity also. Is that okay? So all we're talking about is way out to infinity, or way out to negative infinity, either one, okay? So let's do another one of those. Look at it. Right, so then how about, right, these are little arrows. As x approaches positive infinity, f of x is approaching, remember positive infinity out this direction?
Oh, yeah. So it's approaching infinity.
So it's approaching positive infinity again, is that okay? Is that right?
Yep.
What about when x is approaching negative infinity? Then that's negative infinity there. Is that okay? Should we do another one like this, or there's only one other version? Do you want to see another one like this, or should we just do the other version?
Another version.
All right. You could have something like this. So let's do the easy one first. As x approaches negative infinity, y is approaching negative infinity. Is that okay with that one? All right, what happens if x is approaching positive infinity then? Well, so hopefully I drew it okay.
It looks like it's still inclining right.
Well, so, okay, so that might be because of my drawing, right? Like, I mean, but like if I said this just kind of stays kind of flat, is it the y going to a positive or negative infinity if it's staying flat like this?
No, it's staying the same.
So it's staying the same, and so then it's going to negative 3. Then it's going to negative 3. So it could, right, y value could just go to a number. So often they go to positive or negative infinity, but sometimes they go to just a number. Is that okay? All right. Pretty good. Let's get a look at the